Hello everyone, here we will be discussing exercise problems. Read this question. Two cards are drawn at random and without replacement from a pack of 52 cards. Find the probability that both the cards are black. You are finding the probability of both the cards are black. So let us consider B represent the black cards. How many black cards will be there? 26, right? 26 black cards and 26 red cards will be there. Here we need to find the probability of a black cards. Both should be right. Probability of a black, both should be black. So 26 black cards are there. Now we need to find P of B intersection B, right? Or simply what we can write this as P of B into B, and this is nothing but B is the drawing first card should be black. Then this B is nothing but drawing the second card should be black. So formula will be P of B into P of B by B. One black card is already occurred, so another black. First, what is the probability of a black card? Let B represent a, better you write, let B represent a black card. Then probability of black card. How many will be there? Probability of black card, totally 26 black cards are there. So out of 52, probability of black card will be 26 by 52. Now next, probability of one black card is occurred, right? This is done. This probability is done. Now another probability you have to find. Probability of a second black card where the first black card is occurred. Number of here cards will be, it is given that without replacement. If it is given with replacement, then this is also equal to 26 by 52. Remember, here it is given that without replacement. If it is with replacement, then this is equal to 26 by 52. So already one card is drawn. So remaining black cards are 25 divided by number of cards are remaining 51. So clear? So this is equal to now 1 by 2. Now just you have to substitute here. So P of B into B is equal to probability of B is 1 by 2 into 25 divided by 51. So it's 25 into 1, 25 divided by 1 on 2. So this is the probability of drawing a black card. Both cards are black. This question. A box of oranges is inspected by examining 3 randomly selected oranges drawn without replacement. So we need to draw 3 oranges without replacement. If all the 3 oranges are good, the box is approved for sale. Otherwise it is rejected. So we have to draw 3 oranges. All the 3 oranges should be good. Now what is the probability that a box containing 15 oranges but out of 12 are good and 3 are bad ones will be approved for sale? Simple question this is. Actually no need to use that formula, so directly we can say. But here since it is a theory problem, we need to use the method, or else what we can do. See here, simple it is. We need to draw 3 oranges, right? First is I can say A, B, C. Total how many oranges are there? Total 15 oranges are there, right? In that 12 are good and 3 are bad, right? Total we need to draw 3 oranges. In that total 15 oranges are there. In that also 12 are good and 3 are bad. But all the 3 oranges should be good, right? Here while drawing this, all the 3 should be good. How many oranges is possible here? First orange should be good means total 12 are there. 12 good oranges are there. In that 15 oranges. So probability of this will be 15 out of 12, right? 15 total number of oranges are 15. In that good are 12. So this is done. Now what is the probability of B? 15 are there. 1 is done. So remaining oranges are 40. In that 12 oranges also. Good oranges are there. In that 1 is drawn. Remaining oranges will be 11. Right? Now what is the probability of C? Again we have to draw the good orange. Right? Here in that 14 also 1 is done. How many are remaining? So this will be 13. Right? So how many good oranges are remaining? 10. Simple. So probability, this is a simultaneous process. This is the one. So probability will be 12 by 15 into 11 by 14 into 10 by 30. So this will be the answer for this question. Is it clear? But here we will use the method. Now see here. Let me consider. Let A, B, C are the events drawn first, second and third oranges are good. Okay. Next, what you have to write? Total number of oranges is 15. In that 12 are good and 3 are bad. Next, probability that getting first orange is good. First orange is good. What is the probability of getting the first orange is good? That is P of A, right, will be equal to total number of oranges are 15, in that 12. Next, what you have to write? Probability of getting second orange is good. In that A is already done, right? So B, is it clear? Better to write probability of that getting second orange is good. There A is done, that is probability of B by A will be equal to 11 by 40. Next, probability of getting third orange is good. So there which one is done? A and B are done. So this is occurred already. A and B. So probability of C where A and B are occurred is equal to, it is 10 by 30. Right? Now what you have to find? Intersection. P of A, B, C, or we can write P of A intersection B intersection C is equal to P of A, right? Then probability of this is done. So probability of B and A is done. Probability of B, A is done. Now probability of C where A and B are done. So that is now probability of C where A and B is done. Right? So substituting the formula, P of A is 12 by 15. So this will be 11 by 14 and this will be 10 by 30. Multiply and simplify. Okay. Problem is, a die is marked 1, 2, 3 in red and 4, 5, 6 in green is tossed. Let A be the event, the number is even. B be the event, the number is red. Are A and B independent? Did you understand the question now? What will be the sample space? You are tossing or you are throwing a die. So this will be 1, 2, 3, 4, 5, 6. So this is the sample space, right? What is the set A? A is equal to, it is an even number. Even number is nothing but 2, 4 and 6. What is the even B? Even B is given that B be the event, the number is red. What are the numbers on red? That is 1, 2, 3. So this will be 1, 2, 3. Now find A intersection B. Then find the probability of A intersection B. Check whether P of A intersection B is equal to P of A into P of B. If it is this is true, then we can say that these two events are independent. Okay? Complete this. Given that the events A and B are such that the value of P of A is given, it is equal to 1 by 2, and another one is given P of A union B is equal to 3 by 5, okay, and P of B is equal to P, this is given. Now what you have to find P, the value of P, find P. There are two conditions are given. First one is mutually exclusive, okay, mutually exclusive, and second one is they are independent. So in both the conditions you need to find the value of P, independent. Okay, let's solve this one. Simple it is. See here, first one mutually exclusive. Mutually exclusive is nothing but A intersection B will be equal to empty. That is probability of A intersection B is equal to empty. Now we have the value of P of A union B, right? We'll use this condition to find the value of P. So P of A union B, what is the formula? P of A plus P of B minus P of A intersection B, right? So what is P of A union B? It is equal to 3 by 5 is equal to P of A is 1 by 2 plus P of B is P minus this will be 0. By using simplifying this one, we will get the value of P. Okay, find the value of P. So this is the first one. Second one is they are independent. Independent is nothing but P of A intersection B should be equal to P of A into P of B. Right? P of A intersection B is equal to P of A into P of B. We'll substitute there. So here what we can write, P of A union B is equal to P of same formula, plus P of B minus P of A intersection B can be replaced as P of A into P of B, right? Since they are independent. Now just substitute the values. P of A union B is 3 by 5. P of A is 1 by 2 plus P of B is P minus P of A into P of B. Again same values, 1 by 2 into P. Now simplify this one, only one unknown term is there, so that will get the value of P. Okay, complete this one also. Type of problems are important for 1 or 2 marks. Okay, see this one. A and B are events. P of A, probability of A is given, probability of B is given, probability of A intersection B is also given. Find P not A not B. That means P not A is nothing but A dash and is there. So it will be intersection. Not B means B dash, right? So we need to find P of A dash intersection B dash. By using De Morgan's law, this one we can write as P of A union B whole dash. Right? We have studied this one. A union B whole dash will be equal to A dash intersection B dash. Similarly, A intersection B whole dash will be equal to A dash union B dash. So we'll use this one. So P of A union B whole dash. You know that P of A dash can be written as 1 minus P of A. Right? P of A dash is equal to 1 minus P of A. In the place of A dash, we have A union B whole dash. Right? So this one can be written as 1 minus P of A union B. So clear? So this is equal to 1 minus, what is P of A union B? P of A plus P of B minus P of A intersection B. Right? So this is equal to 1 minus, what is the value of P of A? It is given 1 by 4 plus P of B is 1 by 2 minus P of A intersection B is 1 by 8. Okay? Simplify this one so that we will get the value of P of A dash intersection B dash. Complete this. Okay. Now we will see this question. See here, it is given P of A is equal to 1 by 2, P of B is equal to 7 by 12 and P of not A or not B is equal to 1 by 4. Check, state whether A and B are independent. Okay. First let us write the given conditions, given probabilities. P of A is equal to 1 by 2 and P of B is equal to 7 divided by 12. Now this is P of not A or not P. P of not A is nothing but A dash, or is there, or is nothing but it is a union, right? See the difference? Here and is nothing but intersection. It is common to both. Or is nothing but union B dash. So this one also similar to this. P of A dash union B dash can be written as P of A intersection B whole dash. So clear? By using a De Morgan's law, A dash union B dash is equal to A intersection B whole dash. Again this can be written as 1 minus P of A intersection B. 1 minus P of A intersection B. Here P of A dash union B dash. A dash union B dash is given as 1 by 4. By using this we can write P of A intersection B is equal to, this will be here 1 minus 1 by 4, right? So 1 minus 1 by 4 will be 3 by 4. Now we got P of A intersection B is equal to 3 by 4. What you have to check whether A and B are independent. For that we need to find the value of P of A into P of B. Probability of A is, it is given 1 by 2 into 7 by 12. So this is equal to 7 by 24. You can observe here 3 by 24 is not equal to 7 by 24. So that what we can write, P of A intersection B is not equal to P of A into P of B. So this, by this we can say that A and B are not independent. So you have to solve this. Okay. A and B are independent. The value of P of A is given, P of B is given. Since they are independent, what we can write? P of A intersection B is equal to P of A into P of B. This condition is also given. Now, what is the first problem? Find P of A and B. That means P of A intersection B, right? It will be equal to P of A into P of B. Just you have to multiply this. So that you will get the P of A and B. Here P of A and not B. That means here P of A and intersection not B will be equal to B dash. For this, either you can go with the Venn diagram, you know this, right? If it is A and this is B, intersection with A and B dash. So this is the part, right? A and B dash. So this can be written as P of A. From the P of A, you need to remove the intersection part, right? So you can write P of A minus P of A intersection B. That is the one way. Or else what we can do? See here, A and B, it is given that A and B are independent. We had a result. Whenever A and B are independent, A and B dash is also independent, right? And A dash and B is also independent. And third one is A dash and B dash is also independent, right? We have three results. By using this one, what we can write? Since A and B are independent, okay? Since A and B are independent, that means we can write here A and B dash. A and B dash are also independent. So by this what we can write? P of A intersection B dash. Since they are independent, we can write this as P of A into P of B dash. Now, what is the value of P of A? It is given as 0.3. What is the value of P of B dash? It is not given. But P of B is given, right? P of B is 0.6. So the P of B dash will be, total probability will be 1. Right? B dash will be equal to 1 minus 0.6. Then you need to multiply. Either you can go with, or else you can go with this method. Okay? Any method. P of A or B. So this will be P of A union B. Anyway, P of A is there plus P of B minus P of A intersection B. You have P of A intersection B is equal to P of A into P of last one, P of neither A nor B. That means P of A dash neither A nor B intersection B dash. So you can write this as P of A union B whole dash, right? So this also can be written as 1 minus P of A union B. Anyway, you have the value of P of A union B here. Just substitute here and subtract, so that you will get the answer. I hope you understood these simple problems. This question, this is a direct one. See here, a die is tossed thrice. Find the probability of getting odd number at least once. So die is tossed thrice. You have to find the probability of getting odd number at least once. At least once the odd number should be there, or more than one is also possible. But all the numbers should not be even. Is it clear? At least one odd number should be there, or more than one. But all the numbers should not be even. What we can write for this? Probability of getting odd number at least once. See, can I write like this? At least once is equal to 1 minus probability of getting, okay, odd number. Probability of getting odd number, but I will write properly, okay. Probability of getting odd number in none of the throw. In none of the throw. Probability of getting odd number in probability of getting odd number at least once is equal to total probability. Total will be 1, right? 1 minus probability of getting odd number in none of the throw. In none of the throw is nothing but this probability will be equal to probability of all the even numbers, right? Probability of the even numbers. All numbers should be even. How many even numbers are possible? In a one throw, number of possible, probability of even number will be 3 by 6 in one. So it is equal to 1 by 2. In the second throw is also 1 by 2, right? In the third throw is also 1 by 2. So this will be equal to 1 by 8. Is it clear? So probability of getting all the numbers as even is 1 by 8. I hope you are getting this. Probability of getting odd number or the even number in a single throw will be equal to 3 by 6. That is equal to 1 by 2. Now we have to remove probability of getting all the even numbers, right? All the even numbers means 1 by 2 in the first row, second row is also 1 by 2, third row is also 1 by 2. So it will be equal to 1 by 8, right? So this you have to remove from the total probability. So this is equal to 1 minus all the numbers is equal to even in 1 by 8. So 1 minus 1 by 8 is equal to 7 by 8. So probability of getting at least one odd number will be equal to 7 by 8. This question. Two balls are drawn at random with replacement from a box containing 10 black balls, okay, 10 black balls and 8 red balls. 10 black balls and 8 red balls. Find the probability that first one, both balls are red. First one, both are red. Okay, both are red. One more condition is given. See there. Two balls are drawn at random with replacement. Replacement is possible, not without replacement. It is with replacement. You have to take that ball again. You have to put it back. So it is a with replacement. So both are red. Both are red means total number of balls now. Total it is equal to 10 plus 8 will be equal to 18. So both are red. First we'll find the probability of will represent R as a red ball. Okay. B as a black ball. Now probability of a red ball. What is the probability of a red ball? Total number of balls are 18. In that probability of red will be equal to 8. Right? So probability of red is equal to 8 by 18. Now another is also red. Probability of red, where if you want to get R only or red, one is already occurred but with replacement. So total number of balls now again it is 18. Right? It is given that with replacement. So total number of balls will be 18 and probability of getting red is also 8. So what we can write? P of R, or you can write probability of getting both the balls are red is equal to, write it properly, okay. Probability of getting both the balls are red is equal to 8 by 18 into 8 by 18. And simplify this so that you will get the answer. That is the first one. Second one, first ball is black and second is red. Second question is, first is black and second is red. Now, what is the probability of getting black ball? Probability, first is black, right? So, probability of getting a black ball is equal to, is it clear? Probability of getting black ball, total number of balls is 18. In that black balls 10, right? So that will be 10 by 18. Now one is done. Probability of getting second ball is red. So probability of red where B is already done. Or directly you can write probability of R. No problem. Okay. Probability of R by B is equal to, here replacement is there. So how many balls are there now? Again it is 18, right? With replacement. So number of balls is 18. Number of balls are 18. Probability of getting red. How many red balls are there? It will be equal to 8. Yeah. So this is equal to 8. Now probability of getting first ball is black and second ball is red. So that is, you can write probability of black and R is equal to 10 by 18 into 8 by 18. Simplify this so that you will get the answer. Okay. Now last one more is there in this. One of them is black and other is red. Third one is, one of them is black, one of them is black and other is red. One of them is black and other is red. Now here two possibilities will be there, right? One of them is first black and second red, right? One of them is black, another one is red. So here two possibilities are there. First black, right? First I write B, okay? First black and second red. Yes, this is the one possible. First ball is black and second ball is red. This is a simultaneous process. Plus another possibility is first ball is red. One should be black, another should be red. First black, then red is possible. Or first red, then black is possible, right? So first is red and second is black. Is it clear? Directly I write here, better you write step by step, okay? First ball is black. Probability of getting black, how many blacks are there? 10. In that 18, right? Total number of balls are 18. In that 10 is possible. In second is red. Red, total number of balls are 18. In that red are 8. So this is equal to 8 plus. Because it is a replacement is possible. First is red. First is red. Red are 8. So this will be now 8 by 18 into. So that is second is black. Second is black 10. So it will be 10 by 18. Simplify this so that you get the answer. Okay. I hope you understood this. Simple problems. Okay. You need to understand the question. That's it.